functional analysis and allocation processes allow us to better understand what exactly a system has to do. These functions are analyzed by decomposing the higher level functions that are defined in the original requirements into lower level functions. This results in a description of what each component logically has to do. This is the beginning of what's called the requirements loop. After breaking down each function into smaller components and having a good description of them, then components then can be related back to the original requirements. This is an iterative process going back and forth to make sure your original requirements are met and have some kind of association with each subcomponent. The final component of our systems engineering management model is the process output. This is dependent upon our actual level of development of our product or service. It will include any kind of decisions management is made, system configuration or architecture, baselines, including specifications, and various phases of development. In general, it is anything that describes what our product should look like and how it should function. Now that we have a better understanding of the systems engineering model, I'd like to discuss the document called the Systems Engineering Management Plan. This is basically a document that addresses a company's overall systems engineering management approach. It provides insight into the application of the company's standards, capabilities, configurations, and tool sets for the company. It also describes a company's proposed efforts in planning, controlling, and conducting a fully integrated engineering effort. Breaking down the components of a systems engineering management plan, there are the team organization, the technical environment, also a decision-making process, systems engineering methodology, any kind of external interfaces, also our data management, planning, and any kind of production support strategy for lifecycle management. During the next several slides, I'll go into each one of these in more detail. Starting off, we'll talk about team organization. This is physical location, facility needs, restraints on teams, as well as how each team is structured. Looking at the slide, I have three different types of management structures or team organizations. The top one is a standard structure with a manager and three managers underneath controlling three different groups. Next, we have what resembles to be a matrix type of team organization where each individual can be allocated to another section at any point in time. This is how it's kind of puzzled together, where we can move one puzzle piece from one to the other. Finally, we have my personal favorite, which is more like an integrated product team layout, where you have multiple different groups all focused on one particular area, and in each one of them groups you have one or two members that report back to the leadership team, and that leadership team in turn makes decisions that affect all the groups involved, and that one individual or two individuals that are involved in that leadership team can then go back to their subgroups and make changes accordingly. Going back to our example of the Mustang, here as you can see there's many components involved with the Mustang, whether it's your engine, your wheels, your interior, your drivetrain. The integrated product team that we spoke about last would work fantastic for a situation such as this, where each one is interconnected to the other, but there's no way that one person can have enough knowledge to cover each individual type of component. So in managing the Mustang's development, we have each one of the integrated product teams reporting back to a leadership team, which in turn makes decisions for the product as a whole, which in turn affects each one of the subgroups. This at heart is what systems approach is all about when it comes to managing a product or service. looking at the big picture, in this case the Mustang, being able to break it down into its subcomponents and manage each one of them individually while understanding the effects that each one of them components has on the big picture.